All right, we are doing Jedi Lessons Week 4B. This is Work and Energy Part 1. And today we are going to be talking about kinetic energy and how much kinetic energy between a car. Yay, we have another car. Let me lock in and actually do a decently looking car this time. That one's looking better. Looking better than before. I don't know what's happening. And we are also looking at a bicycle. I rode bikes my entire life. Do I know how they look or anything? No. So we're just gonna do that little C, some like that. I don't know. But we were trying to figure out a 1,650 kilogram car is traveling at 27.4 meters per second. Pretty heavy car. Going pretty fast. How fast must a 91.0 kilogram bicycle and rider, so there's a guy on top too, so we're gonna put a little guy on top, blah blah, he's got little feet, he's doing his thing. How fast must the bicycle and rider be traveling to have the same kinetic energy as the car? So it's gonna be traveling, don't know how many meters per second it is going. Today, as you can tell, we're working with mass, which our SI unit, so we're going to work with mass of the car. SI units is in kilograms, so that will be in our kilograms. We're using velocity of the car. We have the velocity of the car right here. That's in meters per second. We have the mass of the bike plus rider, so we're going to do BR. We have that, 91. And then we are trying to figure out the velocity of the bike and the rider in meters per second. So we're going to write that down. We have 1650, just to keep our numbers in check up here, 27.4 meters per second. We have 91.0 kilograms. And then velocity we don't know yet. And that's part of what we're trying to figure out so that we can get our kinetic energy. So, the kinetic energy, this is our big question. Kinetic energy, the kinetic energy of the bike equals the kinetic energy of the car. So we are trying to figure out the kinetic energy of our car to then figure out our bike. The calculation for this is kinetic energy is 1/2 mass of your object, so this is the bike, times your velocity squared of your object, again, so our bike. And then on the other side is our half times the mass of our car. Velocity squared times the velocity squared times everything else of our vehicle. So if we look at it, what are some things we can do? If we first multiply both sides by 2 to eliminate the fractions, so if we get 2 over 2, multiply those out, it'll then equal, well, if we add them together, then we'll be able to cancel it out to make it 2 over 2, so then it'd be 1, so it really means nothing. So if we do that to both sides, plus 2 over 2, so then it's going to equal our mass of the bike, velocity squared of the bike, equals the mass of the car and the velocity of the car squared. Now, after we do that, we have to get velocity on its own, because that's what we're trying to ultimately figure out, is our velocity. So in order to do that, we are going to divide both sides by the mass of the bicycle, mass of the bike, which then equals velocity squared of our bike with our mass of our car times the velocity squared of our car over the mass of our bike. And then we are going to then figure it out. So once we do this, we are going to then have to, since our velocity is squared, we are trying to find the single velocity. So we are going to throw all of this stuff right here under square root to make this a single velocity. So v of our bike equals the square root, because this is all squared. So when we multiply this, all of this multiplied together will equal the squared version of our velocity, but we're trying to find the square root of this whole thing. So then it's going to be mass of car, v squared over car, because it's still going to be all underneath the square root because it's on the other side of the equation. So we're going to keep it squared. So now we're going to plug in numbers. Velocity of our bike equals the square root. It's a big square root. It's not just the top squared, or square root of the top. It's square root of the whole thing. 1650 times 27.4 meters per second. This is squared, so we have two of them in there, over 91.0 kilograms. This is also in kilograms. Now we're going to do the math. We are going to do square root. This is going to be weird. No, I don't. We're going to do square root of 1650 times, ooh, this is going to be weird. Okay. We're on my calculator, let's see if this will work. 1650 times 27.4 squared. Okay, divide that by 91. So now we have this number, and then we're going to do the square root of the answer, which equals 116. So this equals 116.67 meters per second. So this is the number, this is the velocity of the bike. So this right here is the velocity of the bike, and that is how much kinetic energy is needed from the rider in the bike to be going as fast as the car, which is a lot, which is almost divided by 27.4, which is almost quadruple. It's just over quadruple what the car is doing. That's how much force and energy is needed for the bicycle to travel as fast as the car.